we want to balance a redox reaction. Balancing a redox reaction requires a prior knowledge of oxidation number. Student should know how to find out oxidation number. If a student is able to identify or calculate an oxidation number, balancing a redox reaction will become easy. The first task in balancing a redox reaction, if you really want to balance all the inorganic chemistry reactions, redox reactions, first task is to identify a type. Identifying a type gives us a correct approach for balancing a reaction. Now, if you check the first reaction, then oxidation number of phosphorus is 0, nitrogen is plus 5, hydrogen is plus 1, oxygen is minus 2. On this side, hydrogen is plus 1, phosphorus is plus 5, oxygen is minus 2, nitrogen in this case is plus 4, oxygen is minus 2, hydrogen plus 1, oxygen is minus 2. Now, as an observer, what you are able to get, that oxidation number of phosphorus is undergoing a change. So, phosphorus as an element will be very critical in balance, in balancing a redox reaction. And we are able to identify nitrogen also is undergoing oxidation state. So, phosphorus and nitrogen will be responsible for balancing a redox reaction. Now, this is one of the easiest type and we will call this as type A. Now, if you see second reaction, then Fe has already oxidation state of plus 2 because it is an ion, and Fe is plus 3, that means it is undergoing a change. So, Fe is undergoing oxidation state change. If you check sulfur, in this case sulfur is plus 7, in this case sulfur is plus 6, even sulfur is undergoing a change. So, sulfur will be important. Sulfur is undergoing a change here, ion is changing here. This for us is a simple type of a redox reaction, and for our convenience we will call it as type A. Even third reaction, if you check carbon, you have to know all the oxidation state. Usually, when you have practiced lot of oxidation number related questions, then you can easily identify which are those elements whose oxidation generally change. Carbon is plus 3, oxygen is minus 2, manganese is plus 7, oxygen is minus 2, hydrogen is plus 1, manganese is plus 2 because it is an ion, hydrogen is plus 1, oxygen is minus 2, carbon is plus 4, oxygen is minus 2. Identify those elements whose oxidation number is changing. Carbon is going from plus 3 to plus 4. So, carbon will be critical for balancing a redox reaction. Manganese is going from plus 7 to plus 2. It will be also critical, and manganese is going to one oxidation state, carbon is going to another oxidation state. For us, this is a simple type, we call it as type A. Now, we like to understand other types. If you check copper, it is 0. Copper is going to plus 2. It is undergoing oxidation. Nitrogen is plus 5. And nitrogen goes to plus 2. But if you observe, nitrogen is still plus 5 here because nitric acid, which is made up of nitrate ion, same nitrate ion is present there. Till nitrogen is part of a nitrate ion, oxidation state will remain same. In this case, what you are able to realize, nitrogen exists in two different forms as a product. In one place, oxidation number is same. In the other place, oxidation number is changed. Such type, we will call it as type B. They are not simple one. Copper is going to only one compound, but nitrogen has two different oxidation state in the products. Imagine this one, chlorine is 0 and chlorine is minus 1, changing to one oxidation state. Nitrogen is minus 3. Here also nitrogen is minus 3. Nitrogen, whether it is an ammonia or it is an ammonium ion, it is minus 3, and nitrogen is 0. So, nitrogen is going to two states, one in which its oxidation state is remaining same and the other place its oxidation state is changed. One remaining same, other undergoing a change. For us, this is quite different from the simple redox reaction. We will call it as type B. Coming to other examples. In this case, on a similar grounds, if you check, chlorine is 0, chlorine is -1 and chlorine is +5. So, chlorine is going into different oxidation states and they are not the same as you started with. You started with 0, but you are ending with -1 and +5. At one place it is getting oxidized, at the other place it is getting reduced. Such reactions in inorganic chemistry are called as disproportionation reaction. Disproportionation reaction, and for us we will call them as type C. In type C, oxidation state are two different and they are not the same as a start. In type B, one of the oxidation state is same and the other is undergoing a change. If you check phosphorus 0, in this case -1, in this case +1, it is an example of disproportionation. In one place it is getting reduced, at the other place it is getting oxidized. That means disproportionation for us type C. If you check the next one, xenon is in +4, xenon here is 0, xenon is +6, +4 go to 0, +4 goes to +6, same element undergoing two different change. At one place it is getting reduced, other place it is getting oxidized. Such a reaction is disproportionation for us type C. Coming to more examples, we are trying to see. If you check sulfur, here is 0, sulfur here is +4, sulfur here is +6, sulfur is getting oxidized and sulfur only is getting reduced. Two different oxidation state becoming one. Such a reaction is called as comproportionation. Comproportionation. We'll call this as type D reaction. So how many types? Type A, simple one, 1 to 1, 1 to 1. Type A. Type B, 1 to 2, 1 to 2, where one oxidation state same, other change. Type C, 1 becoming 2, where oxidation states are different than what you started with. Type C, you started with 0, you are getting -1, +1. Type C. Type D, you started with two different oxidation state but they are ending up with only one. That's type D. So, 4 types of different redox reactions will require different approach for balancing. So, we will see balancing for each right in separate session. So, we come to a very interesting topic of balancing a redox reactions. Generally, redox reactions are very difficult to balance and many of you may be following certain methodology or trick to balance such a reaction. So, there is one more trick, a shorter, simpler trick to balance a redox reaction. So, we are seeing reaction number 1, right. If you try to understand, when phosphorus is made to react with concentrated nitric acid, then phosphorus gets oxidized to phosphoric acid and nitric acid gets reduced to NO2. This is what exactly happens. Now, it is a redox reaction where phosphorus is getting oxidized to phosphoric acid and nitric acid is getting reduced to nitrogen dioxide. This is what we like to balance it. So, to balance it, we require oxidation number. So, if you know what is oxidation number of phosphorus in elemental state, 0. And if you try to find out oxidation number of phosphorus in phosphoric acid, then it goes to +5. So, if you try to understand, phosphorus as one single atom goes from 0 to +5, single phosphorus atom. So, there is a change in oxidation state of 5 for one phosphorus. but as a reactant we are not dealing with one phosphorus, we are dealing with a P4 molecule which is made up of 4 phosphorus atoms. So, total change in oxidation number is 20. If you see similarly nitric acid, if you check oxidation number of nitrogen and nitric acid is plus 5 and nitrogen in NO2 is plus 4. So, it is going from plus 5 to plus 4. So, it is undergoing a change by a factor of 1, plus 5 to plus 4 changes by 1 for one nitrogen. But we are looking at nitric acid and nitric acid has only one nitrogen. Because it has only one nitrogen, change is 1. In this case there were 4 phosphorus, remember, therefore we multiplied by 4. Now we know change in oxidation state is number of electrons exchanged. That means P4 as a unit exchanges 20 electron, nitric acid as a unit exchanges 1 electron. But we know for a balanced reaction total exchange of electrons should be equal. Total exchange of electrons should be equal. So, what number should we multiply this side and this side so that change or there is equalization of number of electrons? So, naturally here we multiply by 1. So, 1 with 20, that means 20 electrons are undergoing a change, and in this case we will multiply by 20. 20 multiplied by 1, 20. Or you can simply remember cross multiply. Cross multiply so the total exchange of electrons should be same. So, 20 multiplied by 1, total electron exchange are 20. 1 multiplied by 20, total electron exchange are 20. So, equal or complete exchange of electron is taking place. So, we got numbers on this side. Number with phosphorus is 1, number with nitric acid is 20. Now, the total number of phosphorus atoms on this side and total number of phosphorus atoms on this side should be same. So, naturally I should multiply by 4. So, total number of phosphorus atoms are balanced. Nitrogen is next to be balanced. So, 20 multiplied by 1 nitrogen, that is 20 nitrogen here. So, 20 nitrogen here. What are the first elements that you balance? You have to balance phosphorus and nitrogen. But why? Because phosphorus and nitrogen are undergoing a change in oxidation state. So, they are very critical for balancing and they will decide the balancing. Now, after you have balanced phosphorus and nitrogen, we are left with balancing hydrogen and oxygen. Always balancing oxygen is quite complicated. So, quite easy is balancing hydrogen. So, what we do is we count the number of atoms of other elements. There are only 2 other elements left other than phosphorus and nitrogen. Why we balance phosphorus and nitrogen first? Because they were the elements whose oxidation number were changing. Now, we are left with 2 other elements, hydrogen and oxygen, and we try to balance that. What is the total number of hydrogen on the left hand side? 20. And this number is already there, 12. So, how many more numbers should be there? Naturally, 8 hydrogen should be there. To have 8 hydrogen, you should have 4 here. So, now if you check, right, we have got all the numbers, that means the reaction is balanced. Any balancing can be verified by checking the number on both the sides. Total number of phosphorus atoms on this side is 4. Total number of phosphorus atoms on this side is also 4. So, phosphorus on both the sides, it is balanced. Nitrogen on this side is 20. Nitrogen on this side is 20. So, even nitrogen is balanced. I repeat, we balance phosphorus and nitrogen first because they are undergoing a change. Number of hydrogen on this side 20, left hand side. Number of hydrogen is present here, that is 12 and 8, that is 20. Oxygen which is present here, oxygen is present here only. The number of oxygen present is 60, 60. Number of oxygen present here is 12. Number of oxygen present here is 40 and number of oxygen present here is 4. We did a mistake because number of oxygen here is not 12, is 16, because 4 multiplied by 4, 16, 16, 4 and 40, that is 60. That means all the atoms are balanced. That means the reaction is balanced. So, this is how you are supposed to balance this type of a reaction. We will call this type of a reaction as type A, where only oxidation state of one reactant goes to one more other product and other reactant goes to one more other product. When you will realize other types, you will understand why this is called as type A. So, this was a balancing. Second reaction to balance, where sulfur reacts with nitric acid to give you sulfuric acid, NO2 and water. If you check this reaction, in this reaction sulfur gets oxidized to sulfuric acid and nitric acid gets reduced to NO2. It is also an example of a redox reaction, type A category. That is a simple one. In this case, if you check oxidation number of sulfur, it is 0. In elemental state, oxidation number or oxidation state of an element is 0. If you check for sulfur, it is plus 6. So, sulfur is going from 0 to plus 6. So, it is undergoing a change by 6. This is for one sulfur, but in a reaction we are dealing with S8. S8 means 8 sulfur. 8 sulfur means total 48. So, 48 electrons are exchanged by sulfur. Similarly, if you check for nitric acid, nitrogen is plus 5. Here nitrogen is plus 4. So, it is going from plus 5 to plus 4. It is undergoing a reduction and sulfur is undergoing oxidation, in this case going from plus 5 to plus 4. So, change is by 1. But in a reaction we are dealing with nitric acid, which contains only one nitrogen. Therefore, as a nitric acid, number of electron exchange are 1. Here number of electron exchange are 48. Here number of electron exchange are 1. You take this number here, you take this number here and cross multiply. So, the number here will be 4, no, number here will be 1, number here will be 1 and number here will be 48. 1 for sulfur, 48 for nitric acid. If you check total exchange of electron, 1 multiplied by 48, 48 electron exchange. 1 multiplied by 48, 48 electrons are exchanged. Total exchange of electrons between the two reactants should be equal, which is found to be equal. Now, what we do? We try to balance others. So, sulfur here is 8 sulfur. So, you require 8 sulfur here too. Nitrogen here is 48. So, nitrogen required here is also 48. First, we balance sulfur and nitrogen because they are the critical elements. They decided the right oxidation state and change in oxidation state. Now, write balance and count other elements like hydrogen, oxygen. Now, between hydrogen and oxygen, we try to balance hydrogen because oxygen is quite complicated to balance. So, what is the number of hydrogen? On the left hand side, number of hydrogen is 48. Number of hydrogen here is 16. So, how many hydrogens are required here? Naturally, 32 hydrogens are required here. To have 32 hydrogen, what should be the number present there? Naturally, 16, because 16 multiplied by 2 is nothing but 32. Just check whether we got all the numbers. Yes, we got all the numbers. If you got all the numbers, that means the reaction should be balanced. Now, this as a student for you to check need not be done, right? If you got all the numbers, the reaction has to be balanced. This is just for you, right, to know. In exam or for MCQ purpose, there is no need to such a check. Sulfur present on this side is 8, sulfur present on this side is 8, nitrogen present on this side is 48, nitrogen present on this side is 48. Hydrogen present on this side is 48, hydrogen present here is 16, hydrogen present here is 32, so 48. Oxygen present here is 48 multiplied by 3, that is quite a large number. 48 multiplied by 3. So, you know what is the number 48 multiplied by 3? Yes, it is 144. So, 144 here. How many oxygen here? 8 multiplied by 4, that is 32 oxygen. How many oxygen here? 96. How many oxygen here? 16. Calculate 32, 96 and 16. If you calculate, it will come out to be 144. That means the reaction is balanced. And the balanced reaction is 1S8 reacts with 48 nitric acid to give you 8 sulfuric acid and 48 NO2 plus 16 H2O. That is what we understand by balancing this reaction. Third redox reaction, type A. What is type A? Where one reactant goes to one oxidation state and another reactant goes to another oxidation state, and they are two different substances. It's an easier one, a most common example of redox reaction around. So, it's a common example of redox reaction around. Now, we'll check how to balance such a reaction. This reaction is involving ions, and in this case, what exactly happens? Oxalate gets oxidized to carbon dioxide, while permanganate gets reduced to manganese ions in acidic medium. This is what is happening. What is the oxidation state of carbon in oxalate? +3. And what is the oxidation state of carbon in carbon dioxide? +4. So, what is the change in oxidation state of carbon? Answer is changes by 1, +3 to +4. But you are doing it for one oxalate ion which comprises of 2 carbon. So, for 2 carbon the change is by 2. If you check for manganese, it is +7 going to +2, +7 going to +2. So, what is the change in oxidation state from +7 to +2? Change in oxidation state of manganese is 5, but we are calculating for permanganate ion. As a permanganate ion, there is only one manganese ion, and one manganese ion is involving exchange of 5 electrons. Total exchange should be equal. To do that, we multiply these numbers on this side. So, the total exchange should be equal. For that, what is the number here? Number here will be 5. If you want, you can check. 5 multiplied by 2, 10 electrons exchange. And the number multiplied should be 2. If you multiply 5 multiplied by 2, total electron exchange are 10. So, total number of electron exchange on both the sides are same. Now, what is the next task? We have how many elements? Carbon, manganese, hydrogen and oxygen. As a student, can you tell me which are the elements that you will balance first? Correct, carbon and manganese, because they are undergoing a change. Total number of carbon on this side 10. So, total number of carbon on this side also should be 10. Carbon balanced. Total number of manganese on this side is 2. So, total number of manganese also on this side should be 2. So, even manganese is balanced. Now, the next task is to a balance between hydrogen and oxygen. It is always difficult to balance oxygen. More often it is easy to balance hydrogen. More often. But if you check in this case, we don't have any number with a hydrogen species and we don't have any number with hydrogen species. Because we don't have any number with hydrogen species, right, in this case it will be easier to balance from oxygen's perspective, because oxygen numbers are already done. How many oxygen here? On the left side. On the left side, oxygen here is 20. So, 20. How many oxygen more on the left side? 8. So, 28 oxygen. So, naturally on the right hand side also should be 28. Number of oxygen 20. So, how many oxygen should be present here so that it becomes 28? How much should be present here? Yes, answer is correct, 8. So the number here should be 8 oxygen. So now oxygen is also balanced. Now what next? Hydrogen. Hydrogen on this side is 16. So naturally on this side also should be 16. So 16. Right, now check, all the numbers have come? Yes, if all the numbers have come, that means the reaction is balanced. Right, this is what is a balancing. That means 5 moles of oxalate ions have an ability of reacting with 2 moles of permanganate ion to produce 2 mole of manganese plus 2 and 10 moles of carbon dioxide. But still, for you to understand well, we are doing this simple task of checking whether the reaction is correctly balanced or not. In an exam, it is not necessary, but still we'll go ahead and balance and check. So checking, how many carbons are on this side? Carbon is present only here, that is 10. How many carbons are on the right hand side? It is present only here, 10, so it is balanced. How many manganese are here? It is here only, so 2. Number of manganese present, it's only here, so 2, it is also balanced. Hydrogen are how many? 16 on the left side, on the right side is also 16, so balanced. Oxygen, oxygen is present here, 5 into 4, 20, 20 and this 8, 28 oxygen. In this case, oxygen is 8 in this case, and oxygen here is 20, that's 28. Now the task to check the charge. Charge at this place, at the first one is what? Minus 10. What is the charge with the next one? It is minus 2. What is the charge with the next one? It is plus 16. What is the total charge on the left hand side? Total charge on the left hand side will be plus 4. What is the charge? It is only at this place plus 4 and they don't have a charge. So total charge on the right hand side is plus 4. On the left hand side is also plus 4. So reaction is balanced with even charge. Is it necessary to check all such things? Answer is, it is not necessary to check such things. It is enough. So right, what was the shortcut? Get the total change in oxidation state and cross multiply such the total exchange of electrons should be equal. One more reaction can be also done in the similar manner. One more reaction. If you check manganese, oxidation state here is plus 2 and oxidation state is plus 7. So changes by 5. You are dealing with only one Mn2 plus, so changes by 5. What is the sulfur's oxidation state at this place? You have to find out by redox reaction method. If you want, we can do it. One example for you to understand. 2 sulfur, 8 oxygen is equal to minus 2. Sulfur you don't know. Oxygen is minus 2. Total is minus 2 because total is equal to a charge. If you solve, sulfur will come out to be plus 7. If you check. Now, right, as per inorganic chemistry, sulfur can never have oxidation state more than plus 6. But from physical chemistry perspective, plus 7 is possible. Inorganic chemistry, the answer plus 7 is not accepted. But from redox reaction balancing point of view, allowed plus 7. Here is plus 6. So what is happening to manganese is going from plus 2 to plus 7. So changes by what? 5. Sulfur is going from plus 7 to plus 6, changes by 1. But you are dealing with S2O8. So total changes by what? 2. So total change with this is 2. What we do next? We cross multiply. So the number here will be 2, number here will be 5. Right, once you get this number, what are the other things that you should balance? Manganese, sulfur, hydrogen and oxygen. Manganese on this side is 2, so on this also should be 2. Sulfur on this side is 10, so sulfur here also should be 10. So manganese and sulfur is balanced. What next? Hydrogen and oxygen. If you check, hydrogen number is not there. So who should be used for solving? Naturally oxygen. So how many oxygen on the left hand side? Left hand side oxygen. If you check the number of oxygen here, it is 8 multiplied by 5, that is 40. How many oxygen are here on this side, right hand side? It's 8. How many oxygen here? It is 48. So 8 oxygen here and 40 here, 48. Total oxygen is 48. So how many should be here? 40 plus something. What is that something? Something should be 8. Now, even oxygen is balanced. After oxygen is balanced, what next? Hydrogen. How many hydrogen here? 16. So, total number of hydrogen also should be 16. This is how you can check. Are you understanding it? Right? Is it necessary to check such things? Not necessary. Now, we have already got used to it. So, that was about balancing the reactions of type A category. And this is the answer.